Here we are at the last section of Chapter 3, where we're going to talk about proportional and non-proportional relations. We have a few review problems to start this lesson. So let's look into these, determine whether this sequence is an arithmetic sequence or not. So when I subtract, here I'm going to get plus 4. Here I will get plus 5, plus 6, so I can stop right there and tell you what. There is no common difference. So it is not arithmetic. Find the next three terms of this sequence. Well, if we can determine the pattern, so from 2 minus 3.5 is going to be negative 1.5, and another negative 1.5, another negative 1.5. So I'll be able to just subtract 1.5 and get negative 2.5, negative 4, and negative 5.5. I didn't need the formula because it was just asking me for the next three, and that wasn't too complicated. Now find the equation that represents the nth term of the sequence. So when you hear the words nth term, that means we're going to need to use the formula. So the nth term is the first term plus whichever number term we're looking for minus 1 times the difference. So there's our formula. Alright, so let's find it. And so for this pattern, we need to determine our difference. 17 minus 19 was negative 2. 15 minus 17, negative 2. Negative 2, so D is negative 2. So A to the n equals, the nth term is going to equal our first term, which was 19, plus n minus 1 times a negative 2. So let's put that in parentheses because it's not subtracting negative 2, it's times negative 2. We'll distribute. Negative times negative makes positive. And so A to the n equals, when I combine 19 and 2, I'm going to get 21. So negative 2n plus 21. That was a negative 2n. Sometimes those negatives, my computer for some reason doesn't pick up that negative mark, so please watch for those and help me. I've had to go back and restart several times when I realized it was supposed to be negative and I'm doing the math to a positive number, so help me with that. Alright, so now find the 74th term in that sequence. So now in place of n, I'm looking for the 74th term. Let's change colors. The 74th term, so my n here is 74 plus 21, and that's going to give us negative 148 plus 21. So my 74th term is a negative 127. Alright, now let's get into the new lesson, proportional and non-proportional relations. Alright, let's talk about inductive reasoning. Inductive reasoning is the process of forming a general rule by observing many events. For example, I noticed that every time it rains, the grass grows faster. So from that I can conclude that rain makes the grass grow. That's an observation. Okay? Deductive reasoning is the process of reaching a conclusion by accepting facts or rules. It's because of the facts we can make our conclusion. For example, a doctor gives a patient a strep test. The result of the strep test is positive, so the doctor concludes that the patient has strep. right? Okay. Now, a mother might have used inductive reasoning. I've been there, done that. Inductive reasoning that makes me think that my child has strep throat. So I have a hunch by my observations of what they're saying their symptoms are and maybe the way they're acting. But then the doctor actually knows for sure that it's strep throat based on the facts. So that's the difference in inductive and deductive reasoning. All right, proportional relations. Direct variation, y equals kx, and it always passes through 0, 0. Y is directly proportional, that constant rate of change. It's directly proportional to x. That's where it varies directly, is directly proportional. That's when it passes through 0, 0. Non-proportional relations is when it does not vary directly. Okay? It does not have the point 0, 0. Non-proportional relations does not vary directly. Let's look at the next page. A relationship is proportional if its equation is of the form y equals kx and it passes through 0, 0. So the example they've given us here is y equals 3x. Notice from x to 1, it goes up, it increases 1. Here it increases 1. We're going up by 1 each time. Here the change is increases 3, increases 3, increases 3. So it has the same common difference for both x and for y. So the ratio of the value of x to the value of y is constant. A constant rate of change. That makes it proportional. All right, is this equation proportional? Let's look at it. Y equals negative 2x plus 3. Plus 3 here is where it's going to intercept the y-axis, where it's going to catch the y-axis. So if it's going to pass through the y-axis at 3, which would be up here, then it did not pass through 0, 0. So the answer is no, will not pass through the origin. There was something extra beyond the y equals kx. The extra was the plus 3. All right, these are proportional relationships. They've given them to us. The table shows the number of miles driven for each hour of driving. Sounds like a distance equals rate times time problem to me. That is a direct relationship. Varies directly relationship. Graph the data, and what can you induce? Use inductive reasoning from the pattern about this relationship between the numbers of hours driving, h, and the numbers of miles driven, m. So graph the data. It's already graphed for us. Here it is. I noticed that we increase by 50 each time. And here we're going up in increments of 1. Oops, I'm not making my arcs match up. 1 and 1. So they have a common difference. Every hour that you drive, every hour, it goes up 1 hour each time. For every hour that you drive, every hour you drive 50 miles. And I'm not sure why my screen is blinking. That's what I can induce from this information. Now let's write an equation. to describe the relationship. So our slope, or our rate of change, let's talk about that. The change in y over the change in x, it's going to be 100 minus 50. We already said that difference is 50. And then if I picked 100, I have to pick 2 minus 1, and we already said the change of x values is 1. So really, I could have skipped this step because I already knew that the difference of the y values was 50. The difference of the x values is 1. So my slope is 50. So to write that as an equation, miles or distance equals my rate, which is 50, times my time. And they told us to use m for miles and h for hours. Alright, use this equation to predict the number of miles driven in 8 hours. Okay, so now they're telling us how long we're going to be driving. So here's our equation, and we're going to replace the h with 8. And that tells us we've driven 400 miles. Alright, top of the next page. They're asking us to graph the data in the table, and what conclusion can you make about the relationship between the number of miles walked and the time spent walking. So 1 hour is 1.5 miles, 2 hours was 3 miles, 3 hours 4.5. Okay, so I finished graphing the data. If I check for a common difference, of 1.5 each time, it increases at a constant rate of change. So the difference is the same, and these are all going to be 1, 1, 1. So write an equation to describe this relationship. Well, m equals, or miles, distance equals rate times time. H is for our hours, and our rate of change is 1.5 per 1 hour. For every hour, you're going to walk 1.5 miles. Use this equation to predict the number of miles walked in 8 hours. So m equals 1.5 times hours, and our hours, they're wanting us to check to see what it would be for 8, and we would end up walking, I would hate to walk for 8 hours and only have traveled 12 miles, but that's probably about right. All right, let's look at a non-proportional relationship. Here is some information that is plotted. Remember that if it's non-proportional, it does not pass through 0, 0. So if I look over at these points and I try to draw that line, let's just check and see. It's not going to pass through 0, 0. It just misses 0, 0. And I've just kind of thrown a line up there very hurriedly. But it wants me to write an equation in function notation. Over here I have slope-intercept form. Function notation just means in place of y, use the fancy language of f of x. F of x equals mx plus b. M is my slope, and b is the y-intercept, where it catches the y-axis. I can look here and see my slope is going to be rise over run, rise over run, rise 3, run 1. So I'm using inductive reasoning, looking at my graph. F of x equals slope 3 over 1. You don't need to write the 1, but I will just for the sake of showing you that I actually rose and ran. And then where does it look like it's going to hit the y-axis? Now with my rough sketch, it looks like it hit it at -1. That's using inductive reasoning. With deductive reasoning, I will actually find the points, plug those into the slope formula, and solve for the slope. I've chosen to use 1, 1 here, and I plug in 1 for x and 1 for y using my slope, and I find b. So I was incorrect. My inductive reasoning was not as accurate as deductive reasoning. Try the last problem on the back on your own.